In this video, we're looking at how we can find the derivatives of inverse functions. In fact, in class we learned this nice formula for finding the derivative of an inverse function. Turns out that the derivative of an inverse function is 1 over the derivative of the function evaluated at the inverse of the function. So in this video, we are going to do an example where we use this formula. And also, I'll tell you right now, so that you continue to watch the video, at the end of the video, I will be giving you a problem that you will be expected to do. Okay, so let's use this formula on the following example. Okay, so here's the example. Let's say f of x is equal to the cosine of the natural log of x minus x squared. We are going to try to find the derivative of the inverse function. This is the function. We're going to find the derivative of its inverse evaluated at x equals -10. So what will we need to find in order to answer this question? Well, go back to the formula. We'll have to find the derivative of f, and we'll also have to determine what is its inverse evaluated at -10. Okay, so first let's find the derivative. The derivative of f. Okay, take a look back at the function. The function is the cosine of the natural log of x minus x squared. This is definitely a derivative we can do. Alright, so first of all, what is the derivative of the cosine of something? The derivative of the cosine of something is a negative sine of that something. So in this case, the something is a natural log of x. But the natural log of x is also a function of x, so we have to use the chain rule. So I'm going to multiply times the derivative of the natural log of x, which is 1 over x, minus the derivative of x squared, which is 2x, of course. I can clean this up a little bit. So this is the derivative of f of x is equal to a negative sine of the natural log of x over x minus 2x. Okay, so there's the derivative function. We will have to come back and use that a little later. Now let's see if we can figure out what is the inverse of f evaluated at -10. Well, I truthfully do not know what that number is. In fact, for this function, it could be difficult or impossible to actually find a function for this inverse. We will not find a rule or a formula for that function. But we can still try to find what is the value of f inverse evaluated at -10. Since I don't know what it is yet, I'm just going to say that it's equal to x. And now I'm going to apply the function to both sides. So it's f of f inverse of -10 is equal to f of x. You see, I just applied f to both sides, the left-hand side and the right-hand side. F of f inverse of -10 is just -10, since the function and its inverse sort of undo each other, equals f of x. But we know what f of x is. F of x was given to us as the cosine of the natural log of x minus x squared. And so now we have an equation that we can hope to solve. We can hope to try to solve this for x. So let's see. We have this becomes -10 equals the cosine of the natural log of x minus x squared. Okay, here's the equation. The truth is, algebra is not going to get us the answer here. We're not going to there isn't a way to undo the cosine, also undo the logarithm, and undo the x squared, and isolate this x. But we are not It is not we are not doomed. It is not hopeless. There are other things we can use. We can use technology. We can make a graph. We can try numerical methods. In class, I showed you how to solve equations like this using the calculator. The first step would be to add 10 to both sides. Adding 10 to both sides, we get the cosine of the natural log of x minus x squared plus 10 is equal to 0. So now we have this nice equation that's equal to 0. Using the calculator, you would type in the left-hand side of the equation, make its graph, try to see where does that graph pass through the x-axis so that you find the x-intercepts, which are the roots of the equation, which are the zeros of the function. Okay, so you know how to do this using the calculator to solve for x. I'm going to show you, in case you don't have a calculator with you at home, I'm going to show you how you could use Wolfram Alpha to solve this equation. So let's just remember the equation we're trying to solve. It's this one right here. It's the cosine of the natural log of x minus x squared plus 10 equals 0. I'm going now to Wolfram Alpha, and here's what you can type in. This is in case you don't have a calculator at home. I'm looking at the cosine of the natural log of x minus x squared plus 10 equals 0. Simply type it in like this. Wolfram Alpha probably knows what to do with it. It will probably make a good assumption, but let's just make sure. Let's put in. Let's ask it to solve this equation. Hit enter. We have to give it. A chance to work on the problem. It may take a bit to calculate a result. One thing to notice here is that it actually writes out the equation in a nice looking form. Notice here, instead of a natural log, it says it's a log, and that concerns me until I read their note. It says, for Wolfram Alpha, it says the log of x is the natural logarithm. So when they write log of x, they mean the same thing as we do by the natural log. So here they have come up with a result. They said x is approximately 3.223, and so on. For us, we'll just say x is 3.223. They actually also give a graph. If you were using your calculator, you would be looking for this x-intercept. A left bound, a right bound, a guess. So here we have x is approximately 3.223. Okay? Going back to our work, let's remember that x is approximately 3.223. Okay, so having used some technology or making a graph, we were able to find a solution to this equation. We have x is equal to 3.223. So let's remember what this actually signifies. X is 3.223 is actually telling us, remember, what was x? X was what is the inverse of f evaluated at negative 10. So we now know that the inverse of f evaluated at negative 10 is 3.223. How will we use this? Well, go back to the formula for finding the inverse. The formula is we're supposed to find 1 over the derivative of the inverse function for f evaluated at this point. And now we know this, so let's put it in there. So at this point, what we need to find is, we need to find what is f, the derivative of f, evaluated at, well, we know it's 3.223. We'll have to know that to go further. Do we know the derivative for this function? Yes, we do. We actually found it earlier. We found that the derivative of this function, we found it right here. It turned out that the derivative of this function is negative sine of the natural log of x over x minus 2x. So I will write it down. Just going to write it down so it's easy for us to see. Okay, it's we have the derivative of x was the negative sign of the natural log of x over x minus 2x. And so now we can use this by plugging in 3.223. We can find what we need to know. So let's see. This is the derivative of f evaluated at 3.223 will actually be negative sine of the natural log of 3.223 over, well, this x is also 3.223, then we go to minus 2 times 3.223. See how 3.223 shows up 3 times? That's not a coincidence. The x in this function showed up 3 times, and every place that there was an x, we replaced it with a 3.223. So now we just have to evaluate the right-hand side of this function. Something that you could definitely do using your calculator. I'll show you what it turns out to be on Wolfram Alpha. We just need to remember, it's negative sine of the natural log of 3.223 over 3.223 minus 2 times 3.223. So I'm going back to Wolfram Alpha to find that number. I'm going to erase the previous calculation and try to type this in. So it's the negative sign of the natural log of 3.223 over 3.223 minus 2 times 3.223. Hit enter, give it a chance to work on this calculation. And it says the result is negative 6.73172. Okay? Looks like it may still be working on something. Yes, here's the nice looking version of what I wrote. I'd like to just look at it to make sure I didn't make any typos. 6.223, 3.223, 3.223. This does look like what I intended. Keep in mind that log of x means the natural logarithm here. And the result was negative 6.73172. I'll say negative 6.7317. So let's remember that when we go back to our work. So here's what we have at this point. At this point, we have that the derivative of 3.223 is negative 6.7317. And how do we use it? Well, remember our formula, d dx of the inverse of x, the inverse function, evaluated at x equals negative 10, using the formula, is 1 over the derivative of f evaluated at the inverse function of f evaluated at negative 10. And we have found this, and we have now found this, so we're very nearly done. This is 1 over negative 6.7317. You can simply type that into the calculator, and we get negative 0.14855. That is the answer. I'm going to just summarize the answer in a nice way so I can box it. This is the derivative of the inverse of f of x evaluated at x equals negative 10 is equal to negative 0.14855. While I'm boxing in this answer, I want to ask you this bonus question. Do you know what this derivative is telling us? It may be telling us many things, but one of the important things it is telling us is, I notice that this derivative is negative. And because this derivative is negative, I know that the inverse function is decreasing at x equals negative 10. And that is amazing. It is amazing that even though we don't have the rule or the formula for this inverse function, we still know things about what would its graph be doing right there. We were even able to find the value of this inverse function at a specific value of x, even without knowing its rule. So we can do a lot if we with a few of these tools. Alright, so here we have done a complete example looking at a problem like this, and now I'm giving you a problem to do. So this is completely new now. I want you to do this problem. I'll be giving you this function. Let's let f of x equal e to the x squared plus 1 minus the square root of x. That's what the function will be. And you are to find the derivative of the inverse of this function evaluated at x equals 5. So I'm going to pause for a moment to make sure you can copy this down. You are to take the function f of x equals e to the x squared plus 1 minus the square root of x, and find the derivative of its inverse evaluated at x equals 5.